Welcome to Jeremy's IT Lab. This is a free, complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download and use the Anki flashcards with the link in the description, which will help you very much in remembering what you have learned. Let's get started. So, Day 10's video was quite technical, looking at the details of an IP version 4 header, which is used to encapsulate a layer 4 segment, and then is encapsulated within an Ethernet frame. In this video, we'll get a little bit more practical, and begin to see how routers forward traffic between different networks. Remember, that's the role of a router. Switches forward traffic within a LAN. Routers forward traffic between LANs. So let's take a look at what we'll cover in this video. We'll cover the IP routing process, starting from the end host that wants to send a packet to an end host in another network. I'll give you an overview of the routing process, specifically as it applies to IP, the Internet Protocol. We'll examine the routing table on a Cisco router. Routers keep a routing table, which stores a list of known destinations and how to get there. It's important to be very familiar with the routing table, as you'll be using the show IP route command a lot as a network engineer. Also, we'll look at how to configure static routes, which are routes you manually configure on a router. Here's the network topology we'll be using in this video. Let me give you a quick run-through of the topology. There are two LANs I've illustrated here. This one, connected to R1, is the 192.168.1.0/24 network. PC1 has an IP address of 192.168.1.1, and R1 has an IP address of 192.168.1.254 on its G02 interface. There is also this LAN connected to R4, the 192.168.4.0/24 network. PC4 has an IP address of 192.168.1.4, and R4 has an IP address of 192.168.1.254 on its G02 interface. Those are the LANs, but these four routers represent not a LAN, but rather a WAN, which stands for Wide Area Network. These routers could be kilometers apart, connected by single-mode fiber. Basically, the definition of a WAN is a network that spreads over a large area. Let's look at the IP addresses. Between R1 and R2 is the 192.168.12.0/24 network. Between R2 and R4 is the 192.168.24.0/24 network. Between R1 and R3 is the 192.168.13.0/24 network. And between R3 and R4 is the 192.168.34.0/24 network. I numbered the networks like this to make it easy to understand for this demonstration, but you're probably not going to find networks numbered like this in the real world. But when you're doing labs, it's helpful to make the IP addresses simple to understand. So, PC1 wants to send this packet to PC4. Notice that the source IP address is 192.168.1.1, PC1's IP address, and the destination IP address is 192.168.4.1, PC4's IP address. What does PC1 do from here? First, it asks itself this question: is the destination IP address in the same network? Well, PC1's IP address is 192.168.1.1/24. /24 means that the first three octets are the network portion, so 192.168.1 is the network portion of the address. How about PC4? Its address is 192.168.4.1/24, so 192.168.4 is the network portion. So the answer is no. These two end hosts are in different networks. Because of this, PC1 can't forward the packet directly to PC4. So, because the destination is in a different network, a different LAN, routing logic tells PC1 to send the packet to the default gateway. The default gateway is the device to which the host, in this case PC1, will forward data that is destined for another network. What do you think PC1's default gateway is? The answer is R1. Routers are the devices used to connect separate networks. For example, R1 connects the 192.168.1.0/24, 192.168.12.0/24, and 192.168.13.0/24 networks. So, to reach other networks, an end host will send the packet to its network's router, the default gateway, which is R1 in this case. Now R1 has the packet, and it's R1's responsibility to forward it to the next device. After receiving the packet, R1 will compare the packet's destination IP address to the routing table. As I said in the introduction to this video, each router keeps a routing table, which stores a list of destinations and how to reach the destination. Assuming R1 already has an entry in its routing table for the 192.168.4.0/24 network, the entry will look something like this. First is the destination, which is the 192.168.4.0/24 network. Next is the next hop, the next destination in the path to the 192.168.4.0/24 network, the final destination. And also the interface out of which R1 will send the packet. In this case, R1 could reach the network either by sending it to R2 or R3. But let's say we configured it to send it via R2. As you can tell by both the next hop address of 192.168.12.2 and the exit interface on R1, G00. We'll take a look at configuring routes, as well as take a look at a real routing table on a Cisco router in a few minutes. So, R1 will forward the packet to the next router on the route to the destination, which is R2. So, now R2 has the packet, and it's R2's responsibility to forward the packet to the next device. It will follow the same process as R1. It will compare the packet's destination IP address to the routing table, and then, assuming it already has an entry in its routing table for the destination, it might look something like this. The destination is 192.168.4.0/24. The next hop address is 192.168.24.4, R4's IP address. And the exit interface is G01, which is connected to R4. After looking up the route in the routing table, R2 forwards the packet to R4. Now R4 has the packet, and it is R4's responsibility to forward the packet to the next device. It will follow the same process as both R1 and R2. It will compare the packet's destination IP address to the routing table. In R4's case, the entry in the table will look something like this. 192.168.4.0/24 is directly connected, G02. That's because R4 has an IP address of 192.168.4.254/24 configured on its G02 interface, so it knows the 192.168.4.0/24 network is directly connected to that interface. It forwards the packet out of that interface, and switch 4 passes it on to PC4, the final destination. Now, this has been a very simple overview of how this process works. Notice that I didn't mention MAC addresses or layer 2 at all. This is just a layer 3 overview of this process. I will make a dedicated video called Life of a Packet, in which I follow the same process but go in depth about not just layer 3, but also layer 2. You may have noticed that during this whole process, the source and destination IP addresses have not changed. That is not the case for the MAC addresses, so you'll see that the process is a little more complex than I showed you here. But this basic overview should be enough for you to understand the rest of this video. Let's finally go on to the CLI of a Cisco router. So, we're on the CLI of PC1. Actually, this isn't a PC. Rather than taking the time to set up a virtual PC in GNS3, I just used a Cisco router and changed the icon to a PC. So, we can use this to learn about the Cisco CLI too. So, I used the command show IP route from privileged exec mode, and it displays the routing table. Down here, under the codes at the top, 2 routes are displayed. This may seem like 3 routes, but this line at the top, 192.168.1.0/24 is variably subnetted, 2 subnets, 2 masks, isn't a route. This lists the classful address. And what class is 192.168.1.0/24? It's a Class C address. Underneath are the two routes that fit within that class. If you don't understand this all yet, just wait. We will talk about subnetting, classful, and classless networks a few videos later. For now, just realize that this top line isn't a route. Okay, so we've got two routes, and these two letters on the left, C and L, display the type of route. What do they mean? Well, let's look them up in the list up top. L stands for local, and C stands for connected. What's the difference? Well, let's look at this connected route first. It's a route to 192.168.1.0/24. The IP address configured on PC1's interface is 192.168.1.1/24, so 192.168.1.0/24 is the network address, the address with a host portion of all zeros. /24 means that the first three octets are the network portion, and the last octet is the host portion. Set the host portion to 0, and that's the network address. There are probably lots of other hosts on this network, maybe with addresses like 192.168.1.2/24, 192.168.1.3/24, 192.168.1.4/24, etc. All of them are part of the 192.168.1.0/24 network, because the network portion of their address is the same. So, PC1 knows it can reach any host on the 192.168.1.0/24 network via its network interface, which is Gigabit Ethernet 00 on this Cisco router, which I'm using to simulate a PC. Next up is the local route. Look at this one, 192.168.1.1, which is the exact address on PC1's interface, but this time with a /32 mask. We haven't seen a /32 mask before. /32 would mean that all four octets are the network portion, and there is no host portion. Well, that is correct. You could say this is a route to the 192.168.1.1/32 network, and there is only one address in the network, 192.168.1.1. This is how you identify a single, specific address, by using a /32 mask. So, to recap, the connected route indicates the network to which the interface is attached, and the local route indicates the actual address configured on the interface, with a /32 mask. So that means you already know how to configure two types of routes on a Cisco router. If you configure an IP address on an interface and enable the interface, the connected and local routes of that interface are added. However, this PC doesn't have a route to the intended destination, 192.168.4.1. Actually, that's not a problem. An end host, like a PC, doesn't need to know the route to every destination. All it needs is a default gateway, to which it can send any traffic destined for a location outside of the local network. On a Cisco router, the default gateway is known as the gateway of last resort, and as it says here, it is not set yet. So let's configure the default gateway on our PC, which, as I said before, is actually a Cisco router. To configure the default gateway, also known as the gateway of last resort on a Cisco router, you have to configure what's called a default route. A default route is a route that matches all possible destinations. However, it is used only if a more specific route match isn't found in the routing table. When a router looks up a route to a destination in its routing table, it looks for the most specific match and chooses that route. The default route is the least specific possible route. What does that mean? Well, it uses an IP address of o.o.o.o and a mask of o.o.o.o. So, to set the default route, or gateway of last resort, configure a route to o.o.o.o/o. Think about what that means. The /0 means that there is no network portion of the address, no fixed part of the address that can't change. So that means o.o.o.o/0 covers the range of addresses from o.o.o.o through 255.255.255.255, which is all possible addresses. Let me give a little explanation that might help you understand this. Here is the 192.168.1.0/24 network, like the destination of that connected route in the routing table we just looked at. /24 means that the mask is 255.255.255.0. This mask means that these first 3 octets are fixed. They can't change. However, this part, which isn't covered by the mask, is not fixed. It could be 192.168.1.1, 192.168.1.2, 192.168.1.3, etc. So, 192.168.1.0/24 matches all addresses from 192.168.1.0 through 192.168.1.255. So, how about 192.168.1.1/32, the destination of that local route we saw in the routing table? /32 means a mask of 255.255.255.255. All bits in all octets of the address are covered by the mask. What does that mean? All bits are fixed. They can't change. So that means that 192.168.1.1/32 matches only a single address, 192.168.1.1. That's why the /32 mask is used to specify the exact address configured on the interface in the local route. Now, for the opposite of that very specific /32 address, how about O.O.O.O/O? /O means a mask of O.O.O.O.O, which means that none of the bits in any of these octets are covered by the mask. They are all not fixed. That means that O.O.O.O/0 matches O.O.O.O through 255.255.255.255, which is all possible addresses. I think you can see why I call this the least specific route. It doesn't specify a single address. It includes all possible addresses. So let's get to actually configuring this default route. To do so, we have to learn how to configure a static route. Basically, a static route is a route you manually configure yourself. This is different than the connected and local routes we saw before, which are automatically added to the routing table when we configure an IP address on an interface and enable it. Here's the command to configure a static route. It's IP route, followed by the destination address, the mask for the destination address, and then the next hop IP address. So here, I use the configure terminal command to enter global config mode, and then use the IP route command to configure PC1's default route to R1. Here is the destination address, here is the mask, and here is the next hop IP address, which is R1's. So from global config mode, I used do show IP route to check the routing table once more. And first off, you can see it says gateway of last resort is 192.168.1.254 to network O.O.O.O. The default route also appears down here with the other routes. Notice that the code on the left is different. We have an S and an asterisk. Let's look up top again to see what these mean. S means static, which, as I just explained before, is a route we manually configure on the device, rather than one automatically added like the local and connected routes in the table. The asterisk means it is a candidate default route. The fact that we can see it is added as the gateway of last resort means it isn't just a candidate, it was selected as the default route, but it's still labeled as a candidate default route. Okay, so looking back at our topology, since PC1 now has a default gateway configured, known as a gateway of last resort on a Cisco router, it sends the packet to the default gateway as I showed before. Just a reminder, PC1 isn't actually a PC, it's a Cisco router. Since I'm just using it to ping, I didn't bother setting up a virtual PC, it's easier to just use a router to ping. So since R1 has the packet now, let's take a look at its routing table to see what it will do with the packet. So I used show IP route on R1 and there's the routing table. Because R1 is connected to 3 networks, 192.168.1.0/24, 192.168.12.0/24, and 192.168.13.0/24, it has connected routes for each of those networks, as well as the local routes for the IP addresses configured on its interfaces. However, there's a problem. The packet's destination is 192.168.4.1 in the 192.168.4.0/24 network, but it's not in the routing table. If this were a switch receiving a frame with an unknown destination MAC address, what would it do? It would flood the frame out of all of its interfaces. How about in this case? What will a router do when it receives a packet with an unknown destination IP address? Well, it won't flood it. It will simply drop the packet. Let me review that point. Switches flood frames with unknown destinations, meaning destinations not in the MAC address table. Routers, however, drop packets with unknown destination IP addresses. So, unless we configure a route on R1, this ping will not succeed. So, let's configure a static route on R1 aimed for the 192.168.4.0/24 network. This time, I'll show you a slight variation of the command. IP route, followed by the destination IP address, the mask, and the exit interface. What's different? It's this. Last time we configured the next hop address. This time, instead of specifying an IP address as the next hop, we just specify the exit interface, the interface out of which R1 should send the packet. If we do it on R1, it will look like this. IP route, followed by 192.168.4.0, the destination network, then 255.255.255.0, the mask. Finally, Gigabit Ethernet 00, the exit interface. Okay, so after configuring the route, I used do show IP route on R1 to view the routing table. Here's the route we configured. You may notice an interesting difference here. Because we configured an exit interface instead of a next hop IP address, it says 192.168.4.0/24 is directly connected to the Gigabit Ethernet 00 interface. The code still says S for static though. You can use either way to configure. Later in the course, I'll show you some cases where you will want to use one way instead of the other, but for now you can just use either the next hop IP address or the exit interface. Notice how this static route isn't added as the gateway of last resort, because it is for a specific network, not for O.O.O.O/O, which matches all networks. Okay, now R1 has a route in its routing table for the destination. The destination of this packet is 192.168.4.1, which is included in the 192.168.4.0/24 network. We don't need a route to the exact destination. Because 192.168.4.1 is included in the 192.168.4.0/24 range, it's fine, it matches. So, R1 forwards the packet to R2. You can probably guess that there will be a problem here though. R2 also doesn't have a route that matches 192.168.4.1. So, I went ahead and configured a route on R2, IP route 192.168.4.0, 255.255.255.0, and this time I specified the next hop IP address of 192.168.24.4, which is R4's IP address. You can see the route here. Let's focus on this part at the end, via 192.168.24.4. So, R2 receives the packet with the destination 192.168.4.1 and looks up the most specific match in its routing table. It finds this entry for 192.168.4.0/24, and it says via 192.168.24.4. What does R2 do next? Well, it then looks up the most specific match for 192.168.24.4. That is this route here, which is a directly connected route on Gigabit Ethernet 01, so it will forward the packet out of that interface. So, R2 sends the packet to R4. What happens next? We haven't configured any static routes on R4. Will that be a problem? let's check the routing table on R4. Here's R4's routing table. Because R4's G02 interface has an IP address of 192.168.4.254 configured, the 192.168.4.0/24 network has automatically been added to its routing table as a connected route. So, R4 sends the packet out of its G02 interface, and switch 4 forwards it to PC4. Let's actually try that ping from PC1 to PC4 and see if it works now. So I use the command ping 192.168.4.1 on PC1 to send a ping to PC4. However, as you can see, the ping fails. Success rate is 0%, 0 out of 5. PC1 has a default gateway. All of the routers along the way know how to reach PC4. So what's the problem? The problem is one-way reachability. What does that mean? Well, the packet from PC1 was able to reach PC4. R1, R2, and R4 all have routes to the 192.168.4.0/24 network. However, to send a reply back, PC4 sends packets with a source address of 192.168.4.1 and a destination address of 192.168.1.1. Can you see the problem? R4 and R2 have no route to reach the 192.168.1.0/24 network. R1 can reach it, of course, since it's a connected network, but let's take a quick look at the routing table of R2 and R4 again. Here's R4's routing table. No route to 192.168.1.0/24. And here's R2's routing table. Also no route to 192.168.1.0/24. Not to mention, I also haven't configured the default gateway on PC4. I'll quickly run through the configurations. Okay, so I configured the default route on PC4 like I did on PC1. Same as for PC1, I'm just using another Cisco router instead of an actual PC. You can see the static route I configured, and it has been selected as the gateway of last resort, the default gateway. Here's R4's routing table. You can see the static route I configured to the 192.168.1.0/24 network, and the next top IP address is R2's address. And finally, R2's routing table. Here's the static route I configured to the 192.168.1.0/24 network, with the next top IP address of 192.168.12.1, R1's IP address. Okay, let's try that ping once more. We should have two-way reachability now. Okay, now that we have configured static routes in both directions, you can see that the ping succeeds. Before reviewing and moving on to the quiz, let me clarify one point I mentioned before. Earlier, I mentioned that when a router looks up a destination IP address in its routing table, it looks for the most specific matching route. What does that mean? Well, most specific means the longest prefix length. For example, /32 is more specific than /24, /24 is more specific than /16, /16 is more specific than /8, and /8 is more specific than /0. Here I've added one more link to our topology between R1 and R4. It's the 192.168.14.0/24 network, with R1's address being 192.168.14.1 and R4's 192.168.14.4. I also configured some extra routes. Let's check the route table. So here's R1's routing table now. You can pause the video to take a look if you want. Let's say I issue the command ping 192.168.4.1 on R1. Before thinking about which is the most specific matching route, how many routes actually match 192.168.4.1? Pause the video and find how many matching routes there are. Okay, well, here's one. 192.168.4.1/32 is an exact match. So actually I can tell you right away that this not only matches, it is also the most specific match. 192.168.4.0/24 also matches. Although the last octet is different, .0 and .1, because that octet isn't covered by the mask, it doesn't matter if it changes. It still matches 192.168.4.1. Now, there is one more match. Did you find it? It's this one, 192.0.0.0/8. We haven't seen a Class C address like this with a /8 mask, but it follows the same logic. /8 means that only the first octet is covered by the mask. The other 3 octets can vary, and they will still match. So, 192.168.4.1 does match 192.0.0.0/8. However, as I said, 192.168.4.1 is the most specific route, since it has the longest prefix length, /32. So in this case, the router will choose that route. Here's another example. Ping 192.168.4.254. This time, there are just 2 matches, 192.168.4.0/24 and 192.0.0.0/8. Which route will the router choose? It will choose 192.168.4.0/24 because it has the longer prefix length. Okay, once again, that was a lot of material to cover. If there's anything you don't understand, try watching those parts of the video again. Or feel free to ask questions in the comments. If your question is something I will answer soon in another video, I may just tell you to wait, but I try to respond to every comment. Anyway, before moving on to the quiz, let's review what we covered in this video. We covered the IP routing process, showing how routers look up destination IP addresses in the routing tables to find the next hop in the route to the destination. Speaking of routing tables, I also introduced the routing table on Cisco routers. There's still more to talk about regarding the routing table, but don't worry, there will be plenty more videos about routing coming up. We also looked at configuring static routes using this command, iproute, followed by the destination IP address, the mask, and then either the next hop address or the exit interface. Okay, let's move on to today's quiz. In addition to the quiz, remember to check out the flashcards with the link in the description. They will help you remember what you've learned in this video. Let's get started with question 1. The IP address configured on a router interface will appear in the routing table as what kind of route? A. Static, B. Connected, C. Local, or D. Internal. Pause the video to think about your answer. The answer is C. Local. As you can see here, local addresses use a /32 mask, which specifies the exact address configured on the interface. Connected addresses represent the network that the local address is part of. Static addresses are manually configured addresses, unlike connected and local addresses, which are automatically added when you configure an IP address on an interface and enable it. Internal is not a type of route you can find in the routing table. Let's go to question 2. Which command configures a default route on a Cisco router? Pause the video to examine each option and determine the correct answer. The answer is A. iproute o.o.o.o, o.o.o.o, 10.1.1.254. Default routes are configured as static routes with this syntax. iproute, followed by the destination IP address, the mask, and then the next hop IP address or exit interface. Specifying a destination address of o.o.o.o with a mask of o.o.o.o matches all routes, thus making it a default route that the device uses only if a packet's destination address doesn't match anything else in the routing table. You can't specify a prefix length with a slash in this command. You have to write out the mask in dotted decimal format. Let's go to question 3. Which is an accurate statement about the behavior of routers and switches? A. Routers flood packets with an unknown destination IP address. Switches flood frames with an unknown destination MAC address. B. Routers drop packets with an unknown destination IP address. Switches drop frames with an unknown destination MAC address. C. Routers drop packets with an unknown destination IP address. Switches flood frames with an unknown destination MAC address. Pause the video to think about your answer. The answer is C. Routers drop packets with an unknown destination IP address, but switches flood frames with an unknown destination MAC address. However, you can configure a gateway of last resort on a router, which tells the router where to forward packets that don't match any other address in the routing table. Let's go to question 4. Which two types of addresses are automatically added to the routing table when you configure an IP address on an interface and enable it? A. Connected and static. B. Local and static. C. Default and local. D. Connected and local. Pause the video to think about your answer. The answer is D. Connected and local. As I mentioned in the explanation for question 1, a local route is the actual IP address configured on the interface, and a connected route is the network the interface is a member of. Let's go to question 5. Which interface will be used to forward a packet with a destination IP address of 10.1.1.1? Pause the video to take a look at R1's routing table and find the correct answer. Okay, the correct answer is Gigabit Ethernet 03. The most specific match for the destination 10.1.1.1 is this route, 10.1.1.0/24 via 192.168.14.4. If you then look up the most specific match for 192.168.14.4, you'll find this route to 192.168.14.0/24, which specifies that the packet will be forwarded out of the Gigabit Ethernet 03 interface. Okay, that's all for the quiz. Remember to use the supplementary materials to help you remember what you've studied. There will be Anki flashcards to help you review what you've studied. There will also be a packet tracer practice lab, so you can get some hands-on practice configuring static routes on Cisco routers. Good luck with your studies. Thank you for watching. Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. If you want to leave a tip, check the links in the description. I'm also a Brave verified publisher and accept BAT or Basic Attention Token tips via the Brave browser. That's all for now.